Hi everyone, today I want to talk about the concept of a namespace in Python. And this is an important one because it relates to how Python works internally. Now let's consider this simple assignment statement where we simply take the name string and assign it to a string object with the value Jeff. What happens in Python is that on the left we have this bubble which I call Python names, and that's really what our namespace is. And I will in the future refer to it as namespace. This namespace is where all our names that we assign are stored. And some of the names are already assigned when we start Python. So some built-in names are already there. For example, functions that are there by default. Now, these names are stored with reference, and these references point to the actual object in object space on the right. This object space you might think of as your random access memory, where the objects actually live. Now let's think what happens when we assign the same name, string, to a different object. Well, what happens is that we simply change the reference. Now the same name no longer references the object Jeff, but it now references the object Bob. Now you might think, well, what happens to Jeff? Jeff no longer has a reference and now will be what is called garbage collected. Python has a garbage collector implemented that will simply take care of all the objects that are without assignment. And this will help you clear your memory. Because if the garbage collection would not be there, objects would just accumulate in object space and just clutter it up, and eventually would result in you no longer having enough random access memory. Now let's stick with this example for a little bit. Let's say we have the same thing, string references Jeff. Now what happens when we take another name, new string, and we want to assign it to string? Well, what happens is now we have two names that reference the same object. And this is important because you might imagine there could be a different scenario where now new string refers to a copy of this same object that is essentially equal in value, but is in fact a different object. But both these names now really point to the same object. It's not just equal in value, but it's also equal in its location in the memory. Now let's see what happens as we assign now string to a different object. Well, the same thing happens as before. String no longer references Jeff, but it now references the newly created object Bob. However, Jeff in this example now still has a reference. So Jeff will not be garbage collected, he will stick around. So both these names you can still use to get to these objects. They're still both valid names and they will stick around. Now one important thing about strings is that they are immutable. And that simply means strings cannot be changed, and this causes a great deal of confusion for Python beginners. Because we assign string to Jeff, and then we assign string to Bob. This clearly looks like we changed the object, right? We changed what the string is. But this is not the case, because what we really change is only the reference. We can never change the actual object. We only change the reference. So you can visualize that here. We had string, which used to reference Jeff, now references Bob. But the original object, the original string Jeff, is completely unchanged. It's completely untouched. And we are never able to change what is stored exactly here at this object Jeff, because strings are immutable, in fact. So we never change the actual object with strings, we only change the reference. And this is why it looks like strings are easily changeable. You can just change the string. But that's in a way an illusion. What is changeable is the reference. The reference of a name, or which object a name references, is always changeable. It's always flexible in Python. But objects may be immutable, and as we'll see later, some objects are mutable, and that will open another range of scenarios where we have to look out that we don't change objects by accident. Now, strings are immutable, so let's keep sticking with our example. We've seen functions like this, where we call a function called string.upper, which is supposed to make the string we call it on completely uppercase. Now, what happens as we call string.upper to our string? The answer is absolutely nothing happens. And that is because strings are still immutable. String.upper simply gives us a copy of this same string that is all uppercase, but we don't use an assignment statement here. So this copy will simply get printed to the console possibly, but we never assign it to anything. So what we need to do is we need to assign string upper to another name. In this case, we choose new string. And now, new string refers to a copy of Jeff. That is an entirely different object that is all uppercase. But Jeff, the original string, is still intact. Nothing happened to it because strings are immutable. I cannot repeat this often enough. Strings are immutable. Now what happens if we call string.upper and assign it to the original name, string? Well, the same thing as that always happens. The reference changes. So this is the way to simulate changing the actual object without actually changing the object. So now it looks like you change the actual value of string, but you simply reassigned it. Now, what about numbers? Numbers are also immutable. Here you have a similar example. We assign the name number to the value 5, then we assign number to the value 7, and what happens is, again, we change the reference. We change the reference so that number now points to the value 7, which is an entirely different object than 5. 5 is unchanged, but now that it no longer has a reference, it will just vanish from memory. Now, lists are a different thing. Lists are in fact mutable, and that means we can change lists, but we need a little bit of a different scheme here. So the name myList refers to the object of the list, but that list object itself resolves different parts of it. So this list object lives here, but its single isolated parts then live somewhere else. So the name of my list references an object that in turn references its individual values. Now what happens when we want to change one of the indices of our list? Let's say we want to change the second index, the 3 to a 9. Well, what happens is we change the assignment. And this is a little more complicated. So we go from this list 135 to 195. But numbers are still immutable. So we are unable to change this 3 because lists being mutable doesn't change the fact that numbers are immutable. But what we see here is that this is still the same list in the same place in memory. It's still the same list, but now we change the 3 to a 9. But to do that, we need to change the reference that this list at the second index has from pointing to a 3 to pointing to a 9. Now let's look at another example. Again, same list, but now let's say we want to keep a copy of our unchanged list. So we assign old list to my list. The problem we now have is that old list and my list reference the same object. This was not a problem with strings, because now when we reassign my list with a string, my list would now point to a different object, leaving this one intact. But because lists are changeable, we change the place in memory. We changed what kind of value this index has. And therefore, both these names now point to a changed version of this list. So if our intention was to keep a copy of this old list around that is unchanged, we failed. We introduced a bug. We changed my list and accidentally also changed old list. So how do we work around that? We need to make a copy, and we need to make a copy explicitly. So we need to call mylist.copy and assign it to old list. And this creates an entirely new list that is identical to my list, but it is another object in a different place in memory. And now when we change the second index of my list, we just do that here, because we reference my list and then we change the assignment from pointing to a 3 to pointing to a 9, but old list, the copy, is completely unchanged. Now, this might be a lot to take in, but here are some take-home messages. Names can always be changed, and by that I mean they can always be reassigned. The reference of the name can always be changed to point to a different object. So that part in Python is always flexible. You can always do that. Immutable objects, however, cannot be changed, and by that I mean the actual object in memory cannot be changed. The reference, which type of names point to it, this can always be changed. This is always flexible, but the object itself cannot be changed. When you think you are changing an immutable object, and as you type, as I showed in the examples, you might be under the impression that you actually changed the object. You didn't. You are only changing a copy and reassigning a name. That's what you're in reality doing. You're changing the reference. Mutable objects can be changed, and that introduces another problem. That means that we might accidentally change an object that is referenced by two names. And we have to be aware of that, because if we think that two names reference different objects, but in reality they reference the same object, and we change the object through one of the names, the object as seen through the other name will also be changed. And this can introduce many bugs. And it happened to me many times that I thought I'm dealing with two separate objects, but in reality I just had two different names for the same object, and I changed the object through one of the names and it messed up the other name completely. Now with that I want to finish here. In the next video we will actually Now I want to finish here. In the next video, we will look at some code. How does this look when we're actually programming? And for that, we will also learn about some tools that help us understand the location in memory of an object. And this will allow us to compare not only if objects are equal in value, but if they are equal in location in memory. And this is important to understand namespaces. So I hope this introduction to namespaces helped you. See you in the next video.